Okay, in the last video, we introduced you to solving systems of equations using substitution. We are going to continue to do that, but what we are going to do now is we are going to look at a situation where it's not set up. Actually, no, we're gonna look at one. First of all, I lied. So let's look at a situation where it's not solved for the other variable, and we have to kind of play around with that a little bit. So let's move to number 16 on your sheet if you're following along, and if you're not following along, then just I don't know, just on the sheet, then just write this down. Now, as I write these down, as good old Khan Academy likes to say, if you want to stop the video and go ahead and solve it on your own, please do. All right. Now, on this problem, we've got a situation where we don't have one of these ready to go. It's just not ready to go. The past two situations we've had, you've had a variable that was already solved. So this one, I don't have that. All right, I get both of these are in standard form. So basically, all we got to do is say, well, what do I know how to do? And what I do know how to do is I know I can move things around, and I can solve for any variable in any situation. Even if it doesn't necessarily simplify neatly, I can at least move it around so it looks differently. So what you do is you pick either one of these equations and you say, okay, I'm going to solve for one of the variables. And what I generally look for is I find one that has a variable that has a coefficient of 1 or -1, because that's the easiest to deal with. So that, in this case, that would be this equation right here. And so what we're going to do is we are going to try and solve for y. Now it's -y right now, but we'll deal with that in a second. So let's take this 2x minus y, all right, equals 5, and let's solve for y. Okay, and we're going to solve for y because then we're going to take that, and then once we've done that, we're going to put it into this top equation. All right, so the first thing I'm going to do is I'm going to move this 2x over to the other side. And I know that I can't combine it with the 5 because they are not like terms. If you remember like terms, you can add constants to other constants. You can add other polynomial or monomials to other monomials, right? You can do that. You can't add 5 and -2x because it doesn't make sense. You can't add those and say, oh, I got 3x. That's not how it works. All right, so what that does mean then is we're going to be left with 5 minus 2x, okay? Now, the next thing I'm going to do is I'm going to get rid of this negative because I want to solve for y. I don't want to solve for -y. I want to solve for y. So I'm not quite done. So you got one of two choices. First choice is you can either multiply everything by -1 or you can divide by -1. I'm more of a multiply guy. So let's go multiply by -1. So we are going to do that. So we're going to take this whole thing and multiply it by -1. So -1 times -y gives me my positive y that I'm looking for. -1 times 5 gives me -5. And then -1 times -2x, you got a double neg going there, so that gives me plus 2x. And then let's just rewrite this to get the x in front, just because it looks better. So you get y equals 2x minus 5. So good. All right, so now this is ready to go. All right, and I'm going to be substituting in the other equation with this 2x minus 5 wherever I see y. So the other equation is this 5x minus 2y, right? But I'm not going to write y, am I? No, I'm gonna write minus 2 times, and where we have y, we have 2x minus 5. And so we're gonna have a case where we're gonna have some interesting things going on here. So let's see what excuse me, what that looks like. So we got 5x and then -2 times 2. Now remember, you have to always include the sign, right? So -2 times 2, you have -4x. And then negative 2 times negative 5, because we're multiplying these two, gives us positive 10 equals 14. So before we start moving things around, I have students that like to start moving things around right away. Before we do that, let's collect like terms on this side. All right, so I've got 5x and negative 4x, and that's going to give me 1x. All right, so now I have x plus 10 equals 14. Suddenly this looks very familiar, very easy. We know how to do this. All right, subtract 10 from both sides, and then you get x is equal to 4. So now let's take this and we're going to put it in one of our original two equations. So let's put it in that 2x minus y equals 5. All right, so let's rewrite it down. So 2x minus y equals 5. And I'm going to put 4 in. So you have 2 times 4 minus y equals 5. You have 8 minus y equals 5. Now, at this point, if you see the solution, go for it, right? You ask yourself, what number do I subtract from 8? That will give me 5. Hopefully you'll see that you get 3. Now, if you don't see that, and you're just kind of a robot when you solve things, hey, that's cool. So then let's subtract 8. You get negative y equals negative 3. And then multiply everything by negative 1. And then you get y is equal to 3. So you get to the same place. Just save yourself a little trouble and recognize things. A lot of you like to solve these things in your head anyway, so that's good. This is one case where it's okay. So this is our solution, 0.43. All right, now on the student notes, there is not another situation that applies to this. So we are going to make one up here. Well, I'm not going to make it up. I'm going to pull it out of the book. But let's do one more example. So I have x plus 2y equals 6. And I have 3x minus 4y equals 28. And for those of you that are my students, this is actually for example 2 in the packet that I include on Google Classroom, all right? So the first thing I'm going to do is I'm going to solve, let's look up, the one where I have a coefficient of 1 or negative 1 is the top equation, so we're going to solve for x. So let's take this x plus 2y equals 6, and let's solve for x. So we're going to move that 2y over to the other side. So we're going to get x is equal to 6 minus 2y. Great. All right, now let's go into this first equation, and instead of writing 3x, I'm going to substitute this in for x. So that's going to go right in there, right? So 3 times 6 minus 2y. And then we have the rest of our equation. Just make sure you write it out exactly how it is. So we're going to do our distributive property. 3 times 6 is 18. 3 times negative 2 is negative 6y minus 4y equals 28. All right, starting to look like something. Again, collect like terms first. So I've got a negative 6 and a negative 4y that are both the same kind of term because they have the same variable with the same exponent. So we have 18 minus 10y equals 28. All right, now let's move that 18 over, all right? And you get negative 10y is equal to 10. And you can see that on a lot of these, they start to work out and look pretty nice. All right, so that cancels there. When you divide by negative 10, you get y is equal to 10 divided by negative 10 is negative 1. So let's take this negative 1 now and substitute it into one of those equations. Let's put it in the top one. So let's go, all right, let's go x plus 2 times negative 1, that's my substitution, equals 6. So I have x minus 2 equals 6. We're going to add 2 to both sides. And then you have x is equal to 8. And then just to make sure we did this right, let's look at this equation and put in our solution of 8, negative 1 and see if it works. So 3 times 8 minus 4 times negative 1 equals 28. Well, this is going to be 24, and this is going to be positive 4. So yeah, that works, right? 24 plus 4 is 28. You have 28, sorry, I don't feel like scrolling down right now. I'm being lazy. All right, equals 28. And we're good. So the next video is going to look at when you have different kinds of solutions. All right, thanks for watching. Hope this helped.